half name. Full means even and odd, both even and odd. Is it clear? So once again, good morning, students. So today we are going to study that is harmonic analysis. Here you can see it is a process of finding the constant terms and the first few cosine terms and first few sine terms numerically. Very important. It is numerically, not by using integration. Please remember, this is very easy in the Fourier series part. Very simple part in the Fourier series. You can see it says you are going to find the constant terms. Definitely in the Fourier series also we have calculated the constant term, that is we have calculated, find out the constant term a naught, a and bn. That is what we have done throughout this Fourier series. But here also we will do the same process, that is we are going to find a naught, a and bn, but please remember integration. Therefore it is quite easy, only simple multiplication is there and sine and cosine is there. Numerically we can definitely calculate the Fourier series. Now we'll just see Fourier series of period 2 pi of function y is equal to f of x will be of the form like this, right? You know already the Fourier series f of x is equal to a naught upon 2 plus summation n1 to infinity n cos nx plus summation n1 to infinity bn sin nx, where the Fourier coefficients are here. In the Fourier series we have calculated a naught is equal to 1 upon pi integration c to c plus 2 pi f of x dx, and we have taken this an, that is again Fourier coefficient, an is equal to 1 upon pi integration c to c plus 2 pi f of x cos nx dx, and we have calculated bn is equal to 1 upon pi integration c to c plus 2 pi, yes, f of x sin n pi x dx. So like this we have calculated. But now in the harmonic analysis this is different. What is different? We are not going to use this integration to calculate a naught, a and bn. That is very easiest part in the harmonic analysis. Now you can see in the Fourier series a naught upon 2 is called constant term, right? And you can see the groups of this term. So what I have done, I have taken this Fourier series f of x. This equation I have rewritten once again. A naught upon 2 is same. You can see this is a naught upon 2 is same. Plus from these two terms, that is from this full, what is common I have taken? N is equal to 1 to infinity, that I have taken common. So what is left inside the bracket is an cos nx, right, plus bn sin nx. This is what I have rewritten the Fourier series once again. So here in this now, what will be the harmonics? Yes, please remember now I'm going to write the harmonics. What is harmonic? When I substitute here n is equal to 1, yes, 2 and so on, you can see here this part will become, it is a1 cos x plus b1 sin x. This is known as first harmonic. Is it clear? Similarly, I am substitute n is equal to 2. In this terms, what will happen? a2 cos 2x plus b2 sin 2x. This is known as second harmonic. Please remember this, students. Okay. So they may also give you n is equal to 3. Then it will become third harmonic and so on. So this harmonics continues. So one thing here you have to remember in the harmonic analysis is that the mean value of a continuous function y is equal to f of x in the range a to b is given by, yes, this mean you have to remember, that is 1 upon b minus a integration a to b f of x dx. Is it clear? Suppose y is equal to f of x. We have taken one function having the period at 2 pi. Okay, in c is less than equal to x less than equal to c plus 2 pi, that is we have taken the interval from c to c plus 2 pi. Okay, by periodic property f of x is equal to f of x plus 2 pi. The Fourier coefficient a naught, a n, b n assumes the following form of the above principle. Is it clear, students? So this is what we have the, yes, harmonic analysis. So here again, we'll continue this discussion on harmonic analysis, taking its application. So you can see practical harmonic analysis. So you can see here, students, in many engineering and scientific problems, f of x is not given directly. Definitely, you have seen its students. That is, function is not given directly. Rather, set of discrete values of functions are given in the form. So in the harmonic analysis, directly f of x is not given. Some set of values will be given. That is xi and fi. Okay, where xi's are the equispaced. The process of obtaining f of x in terms of Fourier series from given set of value is known as practical harmonic analysis. Is it clear? So what is saying, if you are going to solve this harmonic analysis, that is practical harmonic analysis, only some values will be given, that is the discrete values of functions will be given. By taking those values, we are going to calculate the harmonic analysis. So please remember, integration is not required because values are given, only we are going to calculate one by one. So in example, it is very clearly you can understand. So we'll continue what is practical harmonic analysis. In a given interval 0 to 2L, f of x is represented in terms of harmonics as shown below. Okay, so as I have told you, this is our Fourier series formula. F of x is equal to n naught upon 2 plus summation n1 to infinity in the bracket an cos n pi x upon L plus bn sin n pi x upon L, where n is equal to 1, 2, 3 and so on. Similarly, we can see this, if you substitute n is equal to 1, please remember, when I substitute n is equal to 1, then this Fourier series, in this Fourier series will known as first harmonic series. Suppose n is equal to 2, if I substitute, this Fourier series is known as second harmonic series. Please remember this, students. So like this, I have taken here, this is for n is equal to 1, first harmonic series, and then n is equal to 2, this is second harmonic series, this is n is equal to 3, third harmonic series, and so on. So this is nth harmonic series. Okay, now what is remaining here, students? To find the coefficient. So I'm going to take the coefficients like this. Fourier coefficient a naught is computed using the relation. So I will make it very simple. So I'm going to take 2 times mean value of y in the interval 0 to 2L, which is a naught is equal to 2 upon m summation I1 to m yi, where m denotes the number of observation. So please remember this, students. Similarly, an and bn can be found out using the relation like this. So an is equal to 2 times mean value of y cos n pi x upon L in the interval 0 to 2L. So this can be written as 2 upon m summation I1 to m yi cos n pi xi upon L. Similarly, bn is equal to 2 times mean value of y sin n pi x upon L in the interval 0 to 2L, which is equal to 2 upon m summation I1 to m yi sin n pi xi upon L. Also, when the interval is 2 pi, suppose instead of 2L, if this is 2 pi, so you can see it is the full length again. Yes, Fourier series length is 2L. 2L is equal to the interval they have given here 2 pi. Yes, interval they have given here 2 pi. So 2L is equal to 2 pi. That implies L is equal to pi. So same equation I can write, f of x is equal to a naught upon 2 plus summation m1 to infinity an cos n x plus bn sin nx. So here you can see, students. So first equation you have to remember a naught. There is no integration. Okay. Similarly, we have an. There is no integration. and then we have bn. So you can see we are not using the integration sign, and which is very very easy. So therefore you have to remember this formula, that is coefficient of Fourier coefficients. You can take a naught, this is our an, and this is our bn. After simplifying you are going to get this three value. Suppose in this, if you substitute n is equal to 1, you will get first harmonic, and n is equal to 3, third harmonic, and so on. So we are not using the integration sign, only they are going to give you some few values, discrete values they are going to give. By using this a naught, an, and bn formula, we'll just compute harmonic analysis, that is practical harmonic analysis we can do. Also you have to just remember here, the amplitude of first harmonic is given by square root of a1 square plus b1 square, and similarly amplitude of second, third harmonic you can change like this, a2 square plus b2 square, square root of, and square root of a3 square plus b3 square. Similarly, respectively, you can calculate the amplitude also after calculating this an and bn. Okay, for f of x, yes, value of Fourier coefficient a naught, an, and bn have been computed using the trapezoidal rule for definite integration. So this is what you have to remember, that is a naught is equal to, that is 2 times mean value of f of x, which is equal to 2 of summation f of x divided by n. Similarly, an is equal to 2 times mean value of f of x cos nx, because this is an is equal to x, which is equal to 2 times summation f of x cos nx upon n. And bn is equal to 2 times mean value of f of x sin nx is equal to 2 times summation f of x sin nx divided by en. So this represents this figure, that is graph. This is, we are going to take, suppose the time interval they have given t, f of t will be this graph you can see here, friends. So for the different harmonics we are going to get this straight curved lines. So they are nothing but the harmonic series. You have seen the sine and cosine series, it was continuous, but here it is harmonic. So this will be first harmonic, second harmonic, third harmonic, like this. This will extend. Is it clear, friends? So just remember this. In the example, you can easily understand here. Is that example? Yes. So here, the first example in the harmonic analysis, student. So without integration, it is quite easy. You can easily solve this. I know it is very easy for you. Harmonic analysis is quite easy than in full Fourier series itself. You can see here, students, that is first example. Determine the constant term and first cosine and sine term of the Fourier series expansion of y from the following data. So as I have told you, only few values will be given, yes, or discrete values will be given here, students. So you can see they have given already discrete values. By using this you can easily calculate a naught, an, and bn. If you simplify this, you will get the definitely the answer. But please remember, here they have given already first cosine and sine terms, means which harmonic this is. This is first harmonic, means n is equal to 1 only are going to see here. I'll show you. It's quite easy, students, and very interesting. Without integration you are going to do Fourier series expansion. Have you thought that? See, here I am going to solve. So please write down this example, students. So you can see here solution. Here you can see what is the interval given. What is interval, students? Yes, x ranges from, this is degree. Yes, x is in degree. So you can see first you have to find the interval. I will tell you what is the interval of x is. So you can see it is starting from 0. This is 45. Then this is again 90, 135, 180, 225, 270, 315. So what is the interval? Yes, it will again, after this it will come to again 360 or 0. Again it will rotate. Therefore the interval we are going to take here, that is from, yes, it is 0 degree to 360 degrees. That is, I can write like this, students. This I can write like this, between 0 to 2 pi. Yes. So what will be the interval I am going to take here? It is 0 to 2 pi. Is it clear? So pi is nothing but 180. 2 into 180 will become 360. Means this x is from 0 to 2 pi. This is what they have given in the table. This is all given here, students. Okay, you have to identify now discrete values. So now in this question, what they have told, we have to find, see, they have told us to find a naught. Okay, so a naught is fixed because definitely nothing is given, is also a naught you have to solve because it is an initial value. Then this is first cosine and sine terms. So please remember, in the harmonic analysis, first harmonic of cosine term is known as A1, and first sine terms in the practical harmonic analysis is known as B1. So you have to calculate here A naught, A1 and Bn, students. Please remember. And as I have told you to remember the formula here, what you have to remember the formula, students? Yes, please remember here formula, that is, I will show you once again. Is that formula? This formulas. So this is what we are going to use the functions now. Functions will become the this interval. Where is this? Yes, this is our function. So function is this discrete values. Is it clear? So I will show you. First, you take x, y, then you have to calculate. Definitely, you have to solve for cos x and sin x. Then you will get the answer. So okay, so we'll solve this. Yes, first you take x value 0, so 45, 90, yes, 135, 135. Yes, students, you should be fast now. 180. You have to first write down the x and y value. Is it clear? Then you have to find one by one. So this is 2, this is 3 upon 2, this is 1, 1 upon 2, this is 0, 1 upon 2, 1 and 3 upon 2. What you have to calculate here, students? Yes, please remember the formula. Shall I write the formula? Which formula I am going to use? You have to solve A naught, A1 and B1. So please remember the formula. So for first harmonic series, wait, I will take this table down only so that I will show you first which formula is going to take. Okay? Yes. Yes. So please remember, means you are going to solve the first harmonic series. Okay, so we'll simplify this now. First, you take the Fourier series. Fourier series for first harmonic. Sorry, this is Fourier series for first harmonic will be, I will take the function now, f of x or y is equal to, this is f of x will become our function. This is equal to a naught upon 2 plus. Now, n is 1, student. Directly substitute n is equal to 1. So what will be this now? Yes, it is a1 cos nx. Nx will become again x plus b1 sin nx. X will become, n is 1. Therefore, b1 sine x. This is our Fourier series. Then what are the coefficient you have to remember here, students? A naught. What is a naught? It is nothing but the mean value. So I'm going to take this as 2 divided by n. This is summation of y. That is f of x. Summation of f of x. Yes, please remember this, students. And a1 will be equal to, yes, students, it is mean value. So 2 upon n summation y here. Yes, it is a cosine function. Therefore, summation y into cos x you have to calculate. And also please remember b1 you have to calculate. The formula will be, this is mean 2 upon n summation y sine x. Is it clear? So that is what we have to calculate. Sum of all this y, sum of all the y into cos x, and this is sum of y into sine x. Yes, students. Now you have to calculate. See, already y you will get easily. What is y? Sum of all the y. Just add these values. Add these values. You will get here summation of y is equal to. So please tell me what is the y value. Then you have to calculate here. Yes, it is y cos x you have to calculate, and y sine x you have to calculate. Then sum of the all values. Please remember. So sum will be, this will become sum of y cos x. This is equal to, and then similarly for sine, this is sum of y sine x. So by taking the discrete value one by one, you can tell me, students, y cos x. Can you tell me what will be y cos x? Yes? See, I will show you one. So y is already given here 2. So in the first place, y cos x can be written like this. So this is 2 into cos x. What is x? 0. Please remember, x is here 0. So this will be equal to 2 into cos 0 is 1. Therefore this is value is 2. Therefore I will write here 2 value. Is it clear? Similarly, y sin x. Okay, I am solving first one. Please solve the remaining terms. I will solve the second one, that is y sin x. Can be written as, now y is here 2, so I will substitute here 2, and then sin x. X is 0, so therefore this is 2 into 0, which is equal to 0. So therefore this value is 0. Is it clear? So this is for first term. Similarly, go for the second one. How we will solve the second one? Same again, y cos x and y sin x. Instead of here y, what you have? 3 upon 2. So I will write here 3 upon 2, and this is 45. Yes, this is 45. So what will be the value? Just calculate. Yes, students, please calculate and tell me. I will show you the second one. Just discrete values are given. We are just calculating the sine series and cosine series without using integration. So by I am going to take in the second one. This is second one. Yes. Y is 3 upon 2. Okay. What I will do? Yes. So y you can take here, friend. This 3 upon 2 is there, and cos 45. Tell me what is the answer. Similarly, this is y is 3 upon 2 sine 45. Yes, students, please tell me what is the answer. Yes, just substitute in the calculator and tell me. Yes, you got 0.06065. Just check. Similarly, sine is 1.06065. Just please check, students. Is it correct? You got the same value? Yes, students? Yes. So you have to multiply here 3 upon 2 cos 45. So have you got the answer? Yes, the next value you are going to get 1.06065.
So my class is at 11. Huh? Because I have an industry talk also today.
This is 1.06065. The next, please check here, students. Go for the next value. Third one. So again, substitute one by one. So third value you have to substitute one by one. So this is y is 1 and cos 90. So 1 into 90. I think cos 90 is what, students? 0. So 1 into 0 will be 0. Similarly, here y is 1 sin 90. So sin 90 is 1. 1 into 1 will be 1. Okay, now so I have to substitute here 0 and 1. Okay, similarly go for the fourth one, students. Yes, please check. If you have any doubt, please ask me. Similarly, go for the third one. Third one, y is equal to 1 upon 2. I will take 1 upon 2 into cos 135. So this is cos 135. Yes, what value we have calculated for the fourth one, students? It is minus 0.49804. Have you got the same answer?
So minus 0.353.
Yes, you're right. 135. Yes, I was just thinking that only. Yes, you're right. So this is you have to take in degrees. Please remember. Yes, so it will be minus 0.35355. Okay, this much is enough. Similarly, y sin x. Then what will be y sin x? Yes, half into sin 135. So you will get here plus 0.35355. Is it clear? Similarly, go for the fifth one, students. Please check. Yes, here you can see y is 0. Means definitely whatever you get here value will be 0 only. Okay, go for sixth one. So again, this is 1 upon 2. What will be this? Into cos 225. Yes, you got the same value, that is minus 0.35355. Is it clear? Similarly, go for sine. So this also we can see it is minus 0.35355. Is it correct? Please check the answers, huh, students. Go for seventh one. Okay. Y into cos x. Y is 1. Okay. 1 into cos 270. Yes. What is 270? It is 0. Okay. Cos is 0. Now sine 270. Yes. It is minus 1. Similarly, go for eighth one, students. So this is 3 upon 2. So this is 3 divided by 2 into, you can see here, students. So it is cos 115. Okay, so I will take here cos 315. Sorry, 315. This is, yes. You can see here value, students. It is 1.06065. Is it correct? Please check the answers once again, students. 1.06065. Okay, this much is enough. I will just round figure it. Similarly, for sine, we'll take for the sine. Yes, 3 upon 2 sine 315. Please check the answers once again, students. If you have any doubt, please ask me. So this is minus 1.06065. Is it clear? Any doubt? Go through the degree. Okay, here x is in degree. Please remember, here in the question they have given x is in degree. If you take radian, you will not get the answer. It will be wrong calculations. Okay, just add this value, students. Now I have to take the summation of y into cos x, summation y into sin x. Okay, so add this value 2 plus 3 upon 2 plus 1 plus 1 upon 2 plus 0 plus 1 upon 2 plus 1 plus 3 upon 2. So what will be the value of summation y? Yes, please unmute and tell me, students. So you can see here, without integration, we have just taken the discrete values and we are going to calculate the Fourier series. So this is very, very simple. Only multiplication is required. Yes, what is the answer here, students? Summation y?
8.
Yes, very good, 8. Similarly, cos x is? Yes, please tell me summation y cos x, students.
3.414.
Very good. You got the correct answer, beta. It is 3.414. Similarly, what about this summation y sin x?
Minus 1.0006.
Yes, please check. See, I will show you here only. See, this plus 0.3535 will get cancelled with this minus 0.3535, right? This will get cancelled with this. So minus 1 will get cancelled with plus 1. Similarly, plus 1.06065 will get cancelled with minus 1.06065. What is the answer?
Zero.
Answer there, 0. 0 is the correct answer. Isn't clear? This is how you have to identify easily. Okay, so you have calculated summation y into cos x, summation y into sin x. Now you have to substitute in this formula. So we'll just take this formula here. Yes. Okay, now I'll substitute all these values in this formulas one by one. Okay, students. So this is equal to. Now we can see what is n. N is nothing but the total number. So you can see this is our total number. So this are number of degrees. So n is equal to how many total number is there? 1, 2, 3, 4, 5, 6, 7, 8. So therefore n is equal to 8. Is it clear? So I'll substitute all the values, friends. So this is 2 divided by 8. Summation y. Summation y is how much? It is 8. So I'll substitute here 8. Similarly, this is equal to a1 I am going to calculate. This is 2 divided by n is 8. Summation y cos x is how much, friends? Yes, it is. Substitute this value, that is 3.4142. Okay, similarly, this is 0. So directly you can see here it is 2 upon 8. Summation y sin x is 0. So now simplify this, friends. So therefore a naught is equal to 8 will get cancelled. This is 2 and a1 sorry, this is a1 is equal to, yes, simplify this value, friends. You must get here value, that is 0.85. Yes, you are right. Right. 0.85355 and b1 you should get as 0. Is it clear? So this is what the Fourier series coefficient a0, a1 and b1. You have calculated the Fourier series coefficient. So you are going to take this Fourier series formula for first harmonic. Please remember this is for first harmonic. Is it clear? So for first harmonic, we are going to take this formula. Here b is missing. b1 sin x. Okay, now substitute all the values. Therefore, Fourier series of y, yes, up to first harmonic is, yes, first harmonic is how many, students? Yes, you can take this as y is equal to a0 is 2 upon 2, this is okay, plus a1 is 0.85355 cos x. Okay, this is 0. Okay, plus 0. Therefore, just you can write this much is enough. That is y is equal to 2 will get cancelled. This is 1 plus 0.85355 cos x is our first harmonic analysis for Fourier series, friends. Yes, friends, if you have any doubt, please ask me.